Hello, everyone. So, I've been wanting to cover this topic for some time now. So, today is the day I've decided to make a video on it. So, I want to talk a little bit about insulation resistance in old electric motors and specifically the effects that moisture and dirt contamination can have on that insulation resistance. So, I figured for a start, we'll take a look at this motor as a real life example of this. This is a over 100-year-old 5 horsepower Century repulsion start induction motor, and this was used on a farm for its entire life. And I don't believe it has been actually run in the last 50 to 60 years, probably. So it's definitely had some exposure to the elements. You can see the entire thing is covered in rust. The windings are pretty well uh, covered in dirt and just all kinds of probably grease, sawdust, whatever kind of other dust might have been on this farm. I think it ran a grain elevator at some point, so it's definitely, the windings are caked with who knows what. So we'll give a little test and see how good the insulation resistance is on this thing. So let's see. I have this old, this is a 1950 Biddle Megger meter. This particular example outputs a 500 volt DC charge across the leads. So I'm going to crank this up and we'll see what kind of insulation resistance we have. The one lead is bonded to the housing of the motor, and the other lead is bonded to the one of the actual motor leads. So this connects to the winding, and we're going to see if we have any leakage through the insulation from the windings to the actual motor housing. So let's see what we get. Okay, so getting about 3 mega ohms. That's not a terrible reading, but it's also not a great reading. Ideally, you would want it to be all the way at the top of the scale towards infinity. And of course, if it was all the way at the bottom of the scale, completely shorted, that would not be good. Now, I did recently restore another Century, and the reading was all the way at the bottom. It was showing that it was completely shorted. And I've actually successfully cleaned and dried and revarnished that winding, and now it has about 500 mega ohms of insulation resistance. So you can certainly bring these things back to life again, provided there's no other damage. It was never burned up. There's no physical damage to the windings that is beyond repair. As long as you don't have anything like that, you can generally always bring these things back. So so this is a real life example of an old motor that has contaminated and damp motor windings. So I'm going to put this Megger meter up on the bench, and we will take a look at a little fun experiment slash demonstration of the effects that moisture has on the insulation. And you'll actually get to see in real time the insulation resistance going down or going back up depending on the moisture content in the insulation. Alright, so here we go for the demonstration part of this video. So I have the same Megger meter from before, and this, for the demonstration, I'm using a piece of 20-pound office paper. This is going to represent the insulation on the motor winding. And then we have the one lead. We'll just say that represents the actual motor winding. And then this other lead will represent the housing or the frame of the motor. So in an ideal, perfect world, there shouldn't be any connection between the winding and the housing of the motor. It should be completely insulated. So with the Megger connected here, if I give this a crank, we should see the needle should read all the way up at the infinity end of the scale. So let's give this a turn. And certainly, that's where it's reading. So now, if I was to represent, say this is a motor that got left outside in the weather, and it got rained on, and it's an open frame motor, so the windings got wet. We'll demonstrate that by adding a little bit of water. Now, I put it on the ends first here, just so that these clips can get a good connection to the actual damp paper. And as you can see right now, just those ends are damp. So if I give this a crank here, we're still on the infinity end of the scale. But now, I need to adjust my spray here so it's a fine mist. If I just lightly mist this with some water, so now that paper is starting to soak up that water and go through the entire thing. Let's see what this measures now. Wow, so we're less than 1 mega ohm. We're maybe 900 kiloohms right now. That's a pretty substantial drop just from getting wet. So you can see how a wet motor winding could definitely cause some problems. Now, we'll wet this just a little bit more. I'm trying not to get the rubber mat completely soaked because it will be harder to dry it out afterwards. Alright, so we're down around 500 kiloohms. So that's a pretty poor insulation resistance reading. If you had a motor and it was reading that, I don't know how confident I would be plugging that in and energizing it under full line voltage. So, let's say you find a motor, it's in this condition, and you want to repair it. You could try drying that winding back out. Now, this is leaving the dirt and contamination aspect of it to the side. If this was a real world motor that we were working on, there would obviously be probably grease and oils and dirt, dust that's built up in those windings, and you would need to clean all of that stuff out before you could proceed with the baking process. But for this, since we're omitting the dirt portion of it, we will be just drying this moist winding. So I'm gonna just apply some hot air, and as we dry this, that insulation resistance should go back up again. And this is simulating if you were to bake the motor winding. As you're driving all that moisture out of it, its insulation is going to improve. So let's see what just that little bit of drying did. We went from 500 kiloohms, and now we're at about 3 mega ohms. So that's about the same as that Century motor was reading. 3 mega ohms. So let's see if we continue to dry this. Let's see what we can get it up to. Now let's see what that does. So we went from 3 mega ohms. Wow. Now we're up to 50 mega ohms. So I could try drying it a little bit more. This would have to really thoroughly dry out to go all the way back up to the infinity part of the scale. We're not going to make this video that long so that you have to sit there and wait through all that drying. but I just wanted to show how this works. So we'll give it one last shot here. All right, it might be getting up around 75 mega ohms there. So this just shows you that as you dry that winding out, the insulation resistance goes up, and it's definitely a smart idea to dry the winding out before you try to energize the motor. If you just find an old motor and you don't even bother to test it, obviously you've got to have one of these testers. You either have to have a hand crank Megger or some kind of like a fluke meter or something that does insulation resistance to test it, but you want to make sure that that winding is dry before you try energizing that motor, just to prevent any further damage that could occur. Alright, so I hope you enjoyed that little demonstration. It was definitely a lot of fun putting this together. Not a whole lot to it, but I think it's really cool to be able to actually visualize and see in real time the Megger meter doing its thing. It's showing you the resistance of that insulation, and when you vary the amount of moisture content in it, you can see that insulation, the resistance go up and down, and being able to watch that happen, I think it's really a neat experience. Alright, so as always, thank you for watching. I hope you enjoyed that as much as I did. It was a lot of fun putting that together. And if you haven't done so already, please like the video and subscribe to my channel, and I will see you in the next one. So have a fantastic day.